So if you've seen our previous video on configuring OSPFv2 on a Cisco router, you've seen how we set up OSPF in this environment. We just did a basic single area setup. Now, in this, I want to talk a little bit about fine-tuning OSPF. So, if you haven't watched the previous video on configuring OSPFv2 on a Cisco router, go find that, watch that first. But if you've seen that, let's go ahead and step into fine-tuning. Now, first thing I want us to look at, we enabled OSPF, let's look at our one here. We enabled OSPF on all three of these networks. And we needed to do that because we needed to advertise OSPF, advertise all three of those networks to our neighbors. When we did that, it also activated the OSPF process on the directly connected interface on that network. And that OSPF process involves sending out hello packets and responding to OSPF messages and things like that. Well, that's great here because we're trying to go through these serial links to connect with these two routers. That's not so good here because I'm sending out OSPF messages to nobody, hopefully. Best case scenario is I'm sending messages that don't need to be there. Worst case scenario is a hacker hooks up and starts trying to pick up those messages and figure out what's going on in my network. So I want to stop those messages being sent out this interface. But I can't take away the configuration that advertises this network. So what we do is we create what's called a passive interface. And we're going to do that in, let me get logged in here, our OSPF configuration. So it's going to be config T, router, OSPF, and we use process ID 1. So I'm going to set my passive interface. And the command is passive, I'll just tab this so you can see the whole thing, passive interface, and I'm going to do G00. And what that does is that keeps me advertising that network, but it stops sending messages out that interface. So if I exit out of here now and do a show IP protocols, we'll see that we're still advertising for that network, but now that's a passive interface, so we're not sending information out of it. Now I don't want to make my serial interfaces passive. Basically anything that's going to connect to another router, don't make it passive. Otherwise, it won't listen for OSPF updates, it won't send OSPF updates, and so it'll never establish a neighbor adjacency. But if you know there's not going to be any other routers out there, make it passive. Let's do the same thing on R2 and R3. Go to our CLI. Config T, router OSPF1, passive interface G00. And the same thing on R3. Config T, router OSPF1, passive interface G00. Okay, now that sets everything to passive, and that's great. Now, let's take a look at our next fine-tuning setting. I'm going to go ahead and exit out of here so we can do some show commands. So I'm going to do a show IP OSPF interface G00. And this is my gigabit Ethernet interface. I want you to look at this right here. Cost is 1. So OSPF uses cost to determine the cheapest route through the network. It's the metric. It doesn't really define what cost is. So what Cisco does is they take the bandwidth and they divide it by what they call a reference bandwidth, which happens to be equal to 100 megabytes. So they take whatever the bandwidth is of the link, divide it by 100 megabytes, and that determines the cost. Now the downside of that is that means a 100 megabit interface and a gigabit Ethernet interface will have the same cost. A 10 gigabit Ethernet interface will have the same cost as a 100 megabit interface. That's probably not what we want. So there's a couple of ways to do this. Number one, we can manually change the cost. And there are some times that we want to do that. We'll talk about that here in a minute. But frequently, The easier way to do it is to change that reference bandwidth. Now, this is something else we're going to do in our router config. But before I do that, I want to do this. I want to do a show IP OSPF interface S000. Now, this has a cost of 64. And we're looking at that. Its bandwidth is assumed to be 1.544 megabit divided by 100 megabit gives you a cost of 64. I want you to see that because we're going to change it here in a minute. So let me go to config T, router OSPF1. And our command is this. It's auto, and I'm just going to do auto question mark. So it's auto-cost reference-bandwidth. And if you don't want to type that much, auto-ref will do the job. So it's given in megabytes. So I'm going to change it to 10,000, which should be equivalent to 10 gigabytes. Now, notice the warning. Reference bandwidth is changed. Please ensure reference bandwidth is consistent across all routers. That's an important point. Because I changed the reference bandwidth here, I haven't changed it on the others yet, which means this one is going to calculate cost different than everybody else. And that's going to lead to some really funky routing issues. But to see for sure that it worked, let's go ahead and exit out. We're going to do the command we did before, show IP OSPF interface S000. And you're going to see that our cost is now 64,776. That's because we changed our reference bandwidth. Let me try that again, 6,476. That's better. That's because we changed our reference bandwidth. And we probably want to do that on everything else too. So let's go to, we just did that on R2, didn't we? No, I just did that on R3. Okay, we just did that on R3. Let's go to R2. And on R2, now remember this interface now has a cost of 64,000. If I go to R2 and look at it, show IP OSPF interface S001, it's still going to show that reference bandwidth, or that cost is 64. So you can see now we have different costs and it's going to screw up our routing. So let's go to config T, router OSPF1, auto cost, reference bandwidth 10,000. And you really want to make sure that you get this consistent across all of your routers to get consistent routing. Otherwise, funky things are going to happen. Config T, router OSPF1, auto cost, reference bandwidth 10,000. And 10,000 is what will give you a difference between 10 gigabit Ethernet and 100 gigabit Ethernet. In fact, if I do I'm doing end instead of two exits here, show IP OSPF interface G00, you'll see that our gigabit Ethernet cost is now 10 instead of 1. A 10 gigabit Ethernet interface will now have a cost of 1. Okay, so we changed our reference bandwidth on everything. However, and just changed our reference bandwidth. Let's say that this link right here, we've tagged it as backup link. Let's say this is a slow backup link. So we don't want to use this link on a regular basis. What we want to do instead is use this link only if one of the primary links go down. So these are our high-speed links, this is our low-speed link. We want all traffic to flow this way. But if I go to R3 and I do a show IP route, we're going to see, let me spread this out a little bit here. You're going to see right here, this network has the same cost. And the way cost is calculated, right here you'll see the metric. The way that's calculated is we add up the cost of all of the interfaces all the way through. So we saw that these serial interfaces now have a cost of 64,000. All right, so to go this way and get to this network, I'll have this 64,000 some odd plus this 64,000 some, which is going to give me a cost of, and we just saw it, 12,952. So, and notice that we have the same cost whichever way we go, if we go this way or this way, which means it is going to load balance across those two. So I want to change this backup link's cost. Now, I said the cost is determined by dividing the reference bandwidth by the bandwidth of the link. So let me go back to, let me make sure I get the right one here, S000. So I'm going to go to my S000 and I want to look at its cost. So I'm going to do show IP OSPF interface S000. And we're going to see the cost is 64,000. Now, there's two ways I can change this. Number one, by the way, changing the cost doesn't change the way the link performs. The link is going to perform the same way. What it does is it changes the way OSPF calculates it. Let me do a show interface S000. When you look at the interface configuration, you're going to see right here the bandwidth. So the bandwidth is 1.544 kilobits. Now I can change that bandwidth using the command in interface config mode, config t interface S000. I can change it using the command bandwidth, and then I can put in the bandwidth in kilobytes. Now that's one way to do it. And some people really prefer to do it that way. You can also change the cost specifically using the command IP OSPF Cost, and I'll question mark that one. So you can see we can have a cost of up to 65,000. We're currently at 6,400. So what I can do is I can change the cost. Now, why would I do one over the other? Well, an advantage of using the bandwidth instead of the cost is it will automatically adjust whenever I change the reference bandwidth. On the other hand, hopefully I'm not doing that often. Hopefully once you get it set, it's pretty much set. So if I'm not doing it that often, that isn't really a huge benefit. The advantage of knowing how to do IP OSPF cost rather than just changing the bandwidth is that not all vendors who make devices that run OSPF will calculate cost the same way Cisco does. So if I know how to do the cost manually, I can make it work in a multi-vendor environment. So I might have a Cisco router connected to an HP router, connected to a Dell router, all of which they calculate costs differently, and it doesn't really matter because I can do cost on my own. So I'm going to do what we're using the cost here, and I'm going to change this cost from, I know it's at 6,400, I just looked at it. I'm going to change it to 10,000. And that's going to adjust my cost. So now if I do a show IP OSPF interface S000, yeah, this one that I needed, my cost is now 10,000. Now, I need to be careful though, because I set it here S000. On R2 S001, if I come here and do a show IP OSPF interface S001, it still has a cost of 64,000. So just, or 6,400. So just like when I changed the reference bandwidth, I needed to do it on all of my devices. In the same way, if I'm doing manually setting the cost, I need to do it on both ends of the link. So I'm going to go to config t interface G0, whoops, do it on the right one, S001 IP OSPF cost 10,000. So I just need to make sure I'm consistent with all of that. So show IP OSPF interface S001 should now have a cost of 10,000. Now, when I come back to R3, remember we had those routes, so we're going equally over the fast link and the slow link. Now if I do a show IP OSPF, whoops, wrong thing, show IP route, that's what I wanted. I don't see that duplicate route anymore. Now it's going to use this path for everything, because which is exactly what I want. I want it going over my faster link, right? Instead of going over my slower link. Now, one more thing, I'm not going to set this, but I want you to see where it's at, and then we'll set one more setting. The other thing I want you to see, but we don't want to set right now, is the intervals. So let me do the command show IP OSPF interface. We'll just play with the same one, S000. Alright. Notice we have two timer intervals here, the hello interval and the dead interval. So the hello interval is how often in seconds we are going to send a hello packet and how often we should expect a hello packet. So I should expect a hello packet every 10 seconds. And I should send a hello packet every 10 seconds. And as long as I get a hello packet every 10 seconds, I know that my interface is good. I know that I'm still connected to that remote device. The dead interval is a timer, and by default it's 4 times the hello interval, hence the reason it's 40. If I don't get a hello packet from the other side within this dead timer, 40 seconds, I will assume that the other side has died. And then I will announce that it's dead and will adjust accordingly. That's what the hello and dead intervals are. And you change them in that configuration mode. So config t interface S000, and the command is IP OSPF, and right here you'll see our dead interval and our hello interval. So you'd say IP hello, let's go ahead and screw it up, hello 5. And so now I'm sending a hello packet every 5 seconds instead of every 10. Now I probably need, every 5 seconds instead of every 10. I'm going to adjust my dead interval as well just to make a match. IP OSPF dead interval, 4 times that would be 20. And so now if I'm going to type do here rather than exiting all the way out, do show IP OSPF interface S000. You'll see that our hello interval and our dead interval have adjusted, and our wait interval automatically adjusted as well. You'll also see that my neighbor adjacency just went down, and this is key. I haven't gotten a hello packet in the time that it was expected, and my adjacency went down. The adjacency goes down automatically because we no longer have equal values. If you have different values for your hello and your dead interval on both sides, it's going to cause your adjacency to break. So again, I've got to do it on both sides if I want it to work. Now in this case, I really don't want it. I want to reset it. I don't have to try to remember what it was though. I can do no IP OSPF hello. No IP OSPF dead, and that will reset those intervals. So now if I type do show IP OSPF interface S000, I can see that my hello and my dead interval have adjusted, and you can see that we've already reestablished our adjacency. Okay, that's how you play with the hello and dead intervals. Why would you want to do that? Well, if 40 seconds is just too long to wait to know if a network goes down, then you can shorten those timers up. However, you're going to use more bandwidth when you do that because you're sending these hello packets more frequently. If you're on a slow link and knowing 5 seconds in if the link went down isn't quite as critical, then you can actually extend that out and use less bandwidth. The bandwidth impact honestly isn't that much. These hello packets are pretty small. So most of the time you're not either going to gain or lose enough to actually notice any difference. But it is there. There will be some. Okay. By the way, I very rarely, if ever, play with the hello or dead intervals. My practice is just leave them alone. Then I don't have to worry about, later on, 6 months down the road, trying to connect something up and it doesn't work, and I have to troubleshoot why, and I'm not forming an adjacency, and it takes me, half an hour to figure out, oh yeah, I changed the hello and the dead intervals. Let me reset it back. So if I just keep it as default, it's a little bit better. All right, last thing. Exit out of here. So here I have a contained network. What about if I want to get out to the internet? So So I'm going to go to R1, and R1 is going to be my internet gateway router. And I actually don't have an internet gateway. I'm faking one here with a loopback interface. So I'm going to do show interface brief. Whoops, show IP interface brief. That'll work better. Okay. So I have a loopback interface here. And I'm going to pretend like this is my default gateway, this is my connection to the internet. So I want to use that as my default gateway. Now I don't want to activate OSPF on here because I don't want to send my routes out to the internet, and I really don't want the internet sending their routes back to me. Most ISPs won't allow you to do that anyway. So what we'll do is we'll set a default static route. So I'll go to config T, and I'm going to do my default static route, IP route 0.0.0.0, 0.0.0.0, so that's my default route, static because I'm manually setting using the IP route. I want it to go over LO1. Now, default route without a gateway, yeah, we don't care. That's fine. So, now if I do a show IP route, I'm going to see right here a static route that is my default route, and that connects me to the internet. But if I go to either of my two neighbors, and I do a show IP route, they don't have that. There's no default static route. I have it on R1, but R2 and R3 don't have it. So what I need to do is I need to get R1 to share that information. And I don't want to create it, I mean I could go to everyone and create a static route, but that's just going to create problems farther on down the road. And you know, it's annoying to have to do that manually when I have this nice little routing protocol sitting here that should do it for me. So what I'm going to do is I'm going to tell OSPF to share that route. Now it's not sharing it automatically because OSPF isn't active on that interface. Remember, we didn't want to do that because, you know, the ISP is not going to appreciate that. So, and we're not going to appreciate it if they did send us all of their routes. So what we're going to do is we're going to go into our global config mode, and then router OSPF1, so our OSPF router configuration, and we're going to tell it, the whole command is default information originate. And it's default dash information space originate. DEFORI will get the job done. And so now let me go ahead and exit out here and show IP OSPF. And this will show, actually I wanted to show IP protocols. Okay. This, notice that we're not routing for that internet network, right? We're only routing for networks that are inside our network, not connected to somebody else. In OSPF terminology, this would be considered an autonomous system boundary router, or ASBR. And what we mean by that is the autonomous system basically means my organization. This is a boundary for my autonomous system. So, great terminology there. But it's a boundary router, so I don't want it routing, I don't want to extend my boundaries and try to encompass all the internet. So that's why we do it this way. And we see that it's not part of our autonomous system, it's not something that we're routing for. If I do a show run though, and I go to my OSPF configuration, here's my OSPF configuration, router OSPF1, and right here is my default information originate, so I can make sure that it's there. Also my passive interface is there. This one, if you remember from our first video in configuring OSPF, we use the network commands. Our reference bandwidth is. So let's see if it worked. Let's go to R2, and on R2 we're just going to re-enter that command, show IP route. And now we have, right here, we learned it using OSPF. The asterisk means it's a candidate default route, which basically means it's our default route. And this is it. The E2 means it's an external route. So we learned it from OSPF, but it's not an OSPF route. R1 just shared it. R1 learned it statically, right? The administrator put it in when we used the IP route command. But it shared that information even though it didn't originate with OSPF, and that's why it shows up as an E2. This, the asterisk and this right here, identifies it as the default route. Come over to R3, we should see the exact same thing there. And if we do show IP route, it means we have propagated our static route. Okay, so we looked at setting the auto cost reference bandwidth, we looked at manually modifying the cost, we looked at setting passive interfaces, we looked at adjusting hello and dead intervals, and propagating default routes, which are all ways to fine-tune and finish out your OSPF configuration.